Section is about perpendicular and angle bisectors. So I'm starting here with the perpendicular bisector. Perpendicular means it meets this segment at a right angle. So this AB is perpendicular to the line segment FG. Meets at a right angle, there's a little box. Bisector means it cuts FG into two equal parts. F to B is the same length as G to B. And perpendicular bisectors are equidistant from the endpoints. Anything on this line, any point, random point like A, is equally distant from one endpoint and to the other endpoint. So F to A is the same length as G to A is. Examples then, R to T. Well, perpendicular bisector, bisector shown by the two little tick marks. If it's 16 from R to S, then it's 16 from R to T. Here's a perpendicular bisector. And if A to B, if the whole length, it's wanting this. Well, it's perpendicular bisector because this AC is equidistant to BC. So that means AD is the same as BD. It was bisected. 2.5 plus 2.5 is 5 for the AB. H to J is the same length as H to K. So we can set up, I'm sure it's 3x plus 1 is the same as 3x minus 1, minus 3, 3x plus 1 equals 5x minus 3, and then you do the math and then plug it back into here. Similar, given that line P is perpendicular bisector of XZ, XY is 15.5, so ZY is 15.5. Given that XZ is 38, Y to X is 27, and Y to Z is 27, so it was on the perpendicular bisector. So if X to Z is 38, it's split in two. Z to W is half of 38, or 19. Given that P is a perpendicular bisector of XZ, X to Y is 4N, Y to Z is 14, so we would set 4N equals 14, divide both sides by 4 to solve for N, which is 3.5, and then given that XY equals ZY, WX is 6x minus 1, and X to Z is 10x plus 16, so then we would do this X to W is the same as Z to W, 6x minus 1, 6x minus 1, 6x minus 1 plus 6x minus 1 equals 10x plus 16, and then we would do algebra. Angle bisectors. This ray, MP, splits this angle, LMN, into two equal little angles. LMP is the same degrees as NMP. That's angle bisector. Any point on that angle bisector is equally distant to both sides of the angle. P to L is the same distance as P to N. P to L is shown at a right angle because you measure distances at a right angle. So P to L would equal a P to N. So here, angle bisector noted by the little curls. So if H to G is 23, then E to H is 23. Okay, QRS, well, if this is 26, this is 26. The distances were the same, so that had to be an angle bisector. So both of the angles are the same. 26 plus 26 for the whole measure of angle QRS is 52. And these two parts are listed the same, so that had to be the angle bisector. So 2x minus 5 would equal, I can't even read if it's minuses or pluses. 2x plus 5 equals 4x minus 25. This one equals this, and then you do the algebra. Here, given that JL bisects these angles, And if L to K is 11.4, then L to H is also 11.4. Or L to H is 26, L to K is 26, so this was the angle bisector. If the whole thing, H to J to K, measure of angle H to J to K is 122, then L to J to K is half of it, 61. So that's the basic idea. Now I want you to look at the next part, which takes those bisectors, those perpendicular bisectors. Here's a line segment, perpendicular bisector, perpendicular and split in two. Here's a line segment, perpendicular at right angle, bisecting. Here's a line segment, perpendicular, bisecting. The three perpendicular bisectors meet concurrently at the same point at this one point M. And the point of intersection of M to R and M to S and M to T is called the circumcenter. Because if you put a compass right there, the point of a compass, and drew a circle, it would encompass and circle this. It would touch N and P and Q, which makes sense because we said on the previous one, perpendicular bisectors equidistant to the endpoints. So that would force M to N to be the same as M to P, would be the same as M to Q. That's what a circumcenter, this point M, does. It's equally distant to the three vertices. So here's a typical. They're saying that those H to D and J to D and K to D are perpendicular bisectors. So they don't have to show us the little boxes or the little tick marks. So it asks, how long is D to G? Well, if D to F is 19, then D to G or D to E, D to G, D to E are also 19. Here, E to K, let's look, E to K. Well, if it's a perpendicular bisector and K to G is 17, then E to K is 17. Similarly, if J to G is 15, then F to J is also 15. They say, okay, where's the circumcenter? Well, perpendicular bisector. Halfway between 0 and 4 is 2. And if you go straight up, because it would be at a right angle, halfway between 0 and 6 is 3. If you went straight to the right, the two of those would meet exactly at that point, which is 2, 3. 2, 3 is the circumcenter. In this one, halfway between 0 and -8 is -4. Halfway between 0 and 5 is 2.5. So this point, -4, 2.5, is the circumcenter. Angle bisectors, we had in the last time too. Split the angle, split the angle, split the angle. Angle bisectors are equidistant to the side. So that forces A to G. A to G and A to H and A to J are angle bisectors. Instead of being called a circumcenter, it's called an incenter. If we put our compass here, made a circle, it would touch B, C, and D. And so that would make AB and AC and AD all radii of the circle, and they would all be the same length. A to B, A to C, A to D, same length. And here's a proof of it. Wouldn't hurt to look at how proofs work. So here's a few of these. PC and PD are angle bisectors. PC and PD. They didn't put the third one. Didn't need it. Find these measures. The distance from P to CE. Well, if P to CD or PQ is 9, P to CE is also 9. Or P to DE is also 9. And this is a curious one. Measure of angle PDE. PDE is right here, and it balances. It's 36 degrees. But most importantly, it's the distance to the side. Here's angle bisectors, and they show us that K to this side is 33. They ask us K to a different side, K to YZ. It would also be 33. That's what you need to know for this section. The first paper I went over was this level 7. These concurrency is level 9. I will put one page, this page right here, on for the assignment, and we will do the CFA for this right when you get back from winter break.